This is PhD Alborz Seddigh Afshar, also known as PhD World Smiler Flow. Yeah, and of course some guy who wants to address me, Prince Regent Wellington, Waterloo. I'm not sure what he's actually calling me. That's so of England or the UK. Yeah, so this is the for someone that dies today, the 16th of May 2015. Alright. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43. 43. Okay. Okay. So it's KSC mostly. Okay. Sure if you can see that KSC. KSC. So C is neutralized by turning into V. K is Kelvin. S is seconds per time. If I want to say surface times velocity is flow. Okay, so that's flow, surface times velocity. Okay, surface times velocity is flow. So the C times of surface is flow. S is K is Kelvin. S is per time of the velocity. Is x per s. Times surface. S is also in the V then also as part of the V. So the V is C is V to neutralize the C. Then the S is x per t, the t part of the x per t is V, and V times surface is flow. Okay, then I work in the that's flow term. I need to turn that into force. Now I work in the Kelvin is temperature, is energy. Okay, is impulse squared per mass equals Kelvin is temperature. Okay, it's a constant times Kelvin temperature. Okay, so that's impulse squared per mass. So if I want to put this relation between impulse squared per mass is T and velocity surface is yeah, flow. Okay, so velocity surface is flow is P, not P squared, is P per m. Okay, it's P per m. Velocity surface. Velocity per surface. Velocity surface per m is velocity surface times m is impulse. Then x times flow times m is impulse times surface. So I would say flow is impulse times surface is flow times m. Okay, then divided by surface. So flow divided by surface times m is impulse times another impulse times p is impulse squared divided by m. Okay, so you got m divided by m is temperature. Okay, So what I do there is this is another term from equals temperature, okay, which the subpart equals force. No, this equals a temperature. Now this is a energy also. It's plus T is plus KT is energy, okay. So impulse times m, no, flow times m divided by surface divided by m times p plus KT is constant times temperature is energy. Both of them are energy terms. Now I divide both by distance. So I divide both by distance, and that turns it into you can make it elegant by scoring the two m's of the first part of the flow energy off, okay. So it turns into a flow times impulse divided by surface, and also divided by x is for the force turning it, so it's divided by volume. So flow divided by volume times impulse is a term for force, plus KT, constant times temperature, is also energy divided by x, is temperature per x, is also a force then, as a type of energy divided by x is also a force. So this is a force that consists of two parts, basically that, yeah. So that's it. That's it. So this is force defined. I multiply both parts by flow constant. What would be 190 something? I'll have to check what force number we're at. So I'll post that online. I think 190 something or 200 something. Okay. So that's a flow constant there, and it's also a flow term. So I think it's my 12th or 13th flow term also as a flow worked into a force. So I can also dice forces that are also flow related as type of a flow term in it. And I'm gonna put a text written with that and put that online. Okay, that's it.